Have you ever wondered what it would take to make Mars habitable for humans? The answer is not as simple as one might think. Mars, our neighboring red planet, presents a thrilling yet formidable frontier for human colonization. To conquer this frontier, we face a myriad of challenges spanning across different domains. From the harsh Martian environment, with its thin atmosphere and extreme temperatures, to the essential survival needs like oxygen, water, and food. Moreover, we need efficient transportation and infrastructure, not to mention the psychological and sociological aspects of living on a whole new planet. Each of these challenges requires innovative solutions and tireless efforts. But don't be daunted, for each problem also opens up new possibilities and invites us to push the boundaries of our knowledge and technology. So, let's dive into these challenges one by one and explore the potential solutions. The first challenge we face is the harsh Martian environment. Imagine an atmosphere so thin that it's primarily composed of carbon dioxide. This is the air, or lack thereof, that greets us on Mars, making breathing a significant obstacle for humans. The solution? We'll need to construct enclosed habitats with controlled atmospheres and advanced life support systems, essentially creating our own little pockets of Earth on an alien world. Now, consider a place where temperatures can swing drastically from day to night, with averages falling far below anything we're used to on Earth. This is the reality of the Martian surface. To create a comfortable and habitable space amid such extreme temperature fluctuations, we'll need to develop advanced insulation and heating systems. The goal here is to maintain a stable, livable environment within our structures, regardless of the Martian weather outside. But it's not just the temperature and atmospheric pressure that pose challenges. Mars lacks a protective magnetic field, a shield that Earth enjoys, which keeps away the majority of cosmic and solar radiation. Without this natural barrier, the Martian surface is exposed to higher levels of radiation. This is where our architectural prowess and technological innovation come into play. We can design radiation-resistant habitats and even consider utilizing underground structures, turning the Martian terrain to our advantage to shield us from these harmful rays. Navigating the Martian environment is a bit like solving a complex puzzle. It demands our inventiveness, our adaptability, and our will to explore and survive in new frontiers. By addressing the issues of atmospheric pressure, extreme temperatures, and radiation exposure, we are taking the first steps towards making Mars a second home for humanity. Now that we've tackled the environment, let's look at the essential needs for survival on Mars. To sustain life on Mars, we must ensure access to oxygen, water, and food. Breathing on Mars is no easy feat. The Martian atmosphere is largely carbon dioxide, and the oxygen levels are a paltry 0.13%, a stark contrast to Earth's 21%. So, how do we ensure a steady supply of oxygen? One possible solution lies in advanced life support systems. These systems can recycle the air we exhale, stripping out the carbon dioxide and replenishing the oxygen. Another intriguing option is algae-based oxygen production. Algae, like other plants, use photosynthesis to convert carbon dioxide into oxygen. We could potentially cultivate these tiny green powerhouses in bioreactors, turning the red planet a little greener. Then there's water. While Mars is famously arid, it's not completely devoid of H2O. The planet harbors subsurface ice, which could serve as a vital water source. Techniques to extract and purify this water will be critical to our survival. Moreover, efficient water recycling systems, akin to those used on the International Space Station, could help us make the most of this precious resource. And what about food? The Martian soil, or regolith, is not exactly fertile. As a result, local food production will necessitate some innovative farming techniques. Hydroponics and aeroponics, which involve growing plants without soil, could be the way forward. These systems use nutrient-infused water or mist, saving space and resources in the process. We could also look into other advanced farming techniques, such as vertical farming within enclosed environments, to maximize production and minimize footprint. In essence, survival on Mars hinges on our ability to adapt to an alien environment and utilize its resources wisely. It's about creating a self-sustaining ecosystem that can support human life, far removed from the familiarity of Earth. And as daunting as these challenges may seem, they also serve as a testament to the indomitable human spirit and our ceaseless pursuit of knowledge and exploration. With basic survival needs addressed, we move on to transportation and infrastructure. The journey to Mars and the construction of habitats present our next set of challenges. For a successful Mars colonization, we need to address two significant challenges: efficient space travel and robust infrastructure. Let's tackle the first one. Imagine a journey that spans millions of miles and takes several months to complete. That's the trip from Earth to Mars. To make this journey feasible and affordable, we need to develop cost-effective and efficient transportation methods. Current advancements in reusable rocket technology are promising. Rockets that can be launched, land back on Earth, and then be launched again can significantly reduce the cost of space travel. This innovation can transform our Martian dreams into reality. But getting to Mars is only half the battle. Once we're there, we need to survive and thrive. This is where the need for sustainable energy sources comes in. Solar power is a natural choice for a primary energy source on Mars. The red planet, despite its distance from the sun, receives a substantial amount of sunlight that can be harnessed using solar panels. However, Mars's infamous dust storms pose a challenge to consistent solar energy production. Hence, we also need to explore alternative energy sources. One such option could be nuclear power, which can provide a steady and reliable energy supply, making it a viable contender for meeting the energy needs of a Martian colony. Next, we need to consider the design of our Martian habitats. These structures need to be capable of withstanding the harsh Martian conditions while providing a comfortable living environment for the inhabitants. One potential solution is to utilize local materials like Martian soil and rocks. Coupled with 3D printing technologies, we can construct efficient habitats right on Mars, reducing the need to transport heavy materials from Earth. With transportation and infrastructure in place, we now turn to the human aspect, the psychological and sociological considerations. Living on Mars will pose significant psychological and sociological challenges. The journey to Mars and the subsequent stay on the planet will involve extended periods of isolation and confinement. This new reality will have profound psychological implications. Imagine being confined within the walls of a habitat for years, with the same faces around you, and the same unchanging landscape outside your window. The monotony can be mentally taxing. To counteract this, we need to implement robust psychological support systems to help individuals manage these challenges. This might involve regular counseling sessions, recreational activities to break the monotony, and strategies for maintaining mental health, like meditation and yoga. The isolation isn't just physical. The time delay in communication with Earth means that real-time conversations with family and friends back home will be impossible. This could exacerbate feelings of loneliness and isolation. Therefore, it's crucial to develop effective coping mechanisms and communication strategies to bridge this gap. Now let's consider the sociological aspects. We're not just talking about surviving on Mars, we're talking about thriving. To do that, we need to build sustainable societies. This requires careful sociological planning. We need to think about the social structures that will govern life on Mars. What kind of governance systems will be in place? How will we manage resources and resolve conflicts? Education will also play a critical role. We'll need educational programs to teach new generations about life on Earth and the history of their Martian society. This will help maintain a cultural link with our home planet and instill a sense of identity and belonging among those born on Mars. In essence, to make Mars habitable, we must consider more than just the physical challenges. The psychological and sociological aspects are equally crucial. We must create an environment that not only sustains life, but also supports mental well-being and fosters a sense of community. Finally, we must consider the importance of international collaboration in this endeavor. The task of colonizing Mars is monumental, and no single nation or private entity can undertake it alone. The success of this mission depends on our ability to work together, combining our expertise, resources, and technologies towards this shared goal. Colonizing Mars is a monumental task that demands global partnerships. On this journey to the Red Planet, it's not about one nation or one company, but rather, it's about our collective human endeavor. Shared research initiatives are at the heart of this. By pooling our knowledge and resources, we can accelerate the pace of progress, overcoming challenges more rapidly and efficiently. Imagine scientists from around the globe, their minds interconnected, working on the same problem, each bringing a unique perspective to the table. The potential for breakthroughs is immense. Cooperative missions, too, play a crucial role. These missions provide opportunities for testing new technologies, sharing costs, and demonstrating the power of unity. Moreover, aligning the goals of different nations and private entities creates a powerful synergy. We're not just working alongside each other, we're working towards a shared vision. The dream of making Mars a second home for humanity is ambitious, but with ingenuity, determination, and global cooperation, it is a challenge we can overcome. As we continue this journey together, exploring the possibilities and challenges of colonizing Mars, we value your engagement and curiosity. We encourage you to share your thoughts, questions, and ideas in the comments section below. Your input not only enriches our collective understanding, but also sparks stimulating discussions. And for those who haven't yet, please do subscribe to our channel for more insightful content on space exploration, technology, and beyond. Remember, the journey to Mars isn't just about the destination. It's about the knowledge we gain, the questions we ask, and the shared excitement of exploring the unknown. So let's continue this adventure together, learning, questioning, and dreaming about our future on the Red Planet. Thank you for being a part of this journey.